Hello students, this lesson is about oxidation numbers. So oxidation numbers are basically, think of those as electron accounting. We're going to account for the electrons that are lost and gained. Today we won't be getting that far into it. We're just going to learn how to assign the numbers so that we can figure out which electrons, how many electrons are lost and gained, and who's gaining and losing them, which entity. But for right now, we just got to learn the accounting rules. So first rule, if it's an element, it has an oxidation number of 0. So Fe solid is an element, that's a 0. Cl2 is an element, 0. Cu solid, 0. Gold, 0. If I gave you this, Au3 positive, that's a gold ion, its oxidation number would not be 0, it's something else. But when you're dealing with elements, the oxidation number is 0. Rule number 2, simple ions or monatomic ions equal the charge. So Fe2 positive is +2, Cl negative is -1, Cu positive is +1. Okay, so simple ions, the charge is the oxidation number. Okay, so if I give you gold ion with 3 positive charge, it would be a +3. All right, hydrogen in most molecules has an oxidation number of +1. So hydrogen, 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 they're all +1s. I would say 95% of the time we're going to have the +1. Every once in a while we might see this situation. A hydride like sodium hydride or lithium hydride, when hydrogen is attached to those a metal, the oxidation number is -1. Honestly, that's pretty rare, but we could ask you questions about it. Okay, oxygen, again, in most compounds is a -2. So again, 95% of the time you're going to throw down a -2 for oxygen when it's in a compound. But it could be -1 if it's with the peroxide ion. So that's hydrogen peroxide there, barium peroxide here, -1. Again, rare, but we could throw those at you. Okay, keep going. Group 1A elements, in a compound, the oxidation number is +1. So sodium's in the first column on the periodic table. It's group 1, it's +1. Group 2 elements have an oxidation number of +2 when they're in a compound. And fluorine is always, because it has a really high electronegativity, is always -1. It steals everybody's electrons. Okay, all other oxidation numbers are assigned so that the sum of the oxidation number equals the charge of the compound. So, take a look at the compound. We don't know what carbon is. We do know oxygen is -2. And the charge on that whole compound is 0. Like, you don't see a charge there, right? It's not like it has a 3 negative off of it. It's just CO, carbon monoxide, 0. So I have to, when I do the math, if I add something to -2, it has to equal 0. So that means carbon has to be +2, because +2 and -2 is 0. Look at this next example. My oxidation number is -2, but I got 2 of them, so I'm at a -4, so mathematically, so my carbon has to be a +4. Okay, this one I'm at a -2, but times 5, so I'm at mathematical -10, and so this has to be +5, and times 2 gives me my +10, which equals 0. Now look at this next one. My O is a -2. I got 3 of them, so I'm at -6. But the whole thing has to equal -2 this time. The charge on the compound is 2 negative. So it's +4, and a -6 gives me a -2. Okay, so in this next one, I know H is +1 from my rules. Hydrogen is almost always a +1. O is a -2. I got 3 of them, so I'm at -6 mathematically. +1, -5. I've got to equal -1, so C is a +4. This one, sodium's in group 1, so it's +1. H is +1. O is a -2. What's C? It's got to be +4. Because 4 + 1 + 1 is 6, and -2 times 3 is -6, must equal 0. Sometimes we've got to get a little more algebraic. So H is a +1, the other H is a +1, the O is a -2. What's the C? Well, I've got 5 of those C's, so I'm going to call that 5x. And when I do the math on the other ones, I've got 4 H's at +1, so that's 4 positives, plus that other H, 5 positives, minus the 2 off the O, so I'm at +3. So 5x plus 3 equals 0, so 5x equals -3 when I subtract my 3 to get rid of my +3. And then, to get x by itself, x equals -3/5. Okay, couple other things. How do you assign oxidation numbers when there's more than one unknown, especially in an ionic compound? It's easy. I don't know what CO is. I don't know what N is. I know what O is, -2, but I can just split it into its ions and deal with it separately. CO just by itself, CO2 positive, is +2. NO3 negative, the O is a -2, times 3 is -6, and it's got to equal -1, so I got a +5. Now if I just transfer those up there, I've just found my oxidation numbers. +2, +5, -2. And if we look at a molecular compound and we draw it this way, if you look at the electronegativities, N is a 3 and the I's are 2.7. So when the N and the I have a tug-of-war for electrons, the pull is towards N. N wins the tug-of-war. The electrons are pulled closer to it than to the I's. So N is having this 3-way tug-of-war with I's, and it wins every time. So it's pulling electrons towards it. It's getting a negative charge from one of them, a negative charge for the second I, and another negative charge from the third I. So it's gained like 3 electrons, partially. And the other ones have lost 1 electron each. So N's oxidation number is a -3, and I is a +1. Okay, that is how you do oxidation numbers. And now there's a bunch of work to do.